Alright, welcome to a second example from 9.1. We're going to look at number 16. I think we'll be able to do this one a little bit faster than the last video, but we'll see. I'll still want to give the same instruction and talk about all of that. And so what's happening here is we have some insecticide-treated bed nets and some non-insecticide treating bed nets, or infants not even using bed nets at all. And so let's look at those two populations. We have the population where the children were given bed nets, and let's go get the information among them. Among 343 infants using bed nets, so the number using bed nets was 343, and then they want to know how many developed malaria, right? The incidence of malaria. There were 15 that developed malaria. Then we have some non-bed nets, right? And so I would recommend just no bed nets. I'd recommend just getting those two populations out there. Call the first one number 1, the second one number 2. It really doesn't matter. And 2, right, it's our second population, would be 294. And the malaria number that contracted malaria was 27 in that group. And we want to use a 0.01 significance level to test the claim that the incidence of malaria is lower for infants using bed nets. Okay, and so they want us first to test it using a hypothesis test. No problem. Our claim, so this is A, our claim is that P1 is less than P2, right? That the incidence of malaria, right? The rate of malaria is lower for infants using bed nets than no bed net. So our null hypothesis is always P1 is equal to P2, and our H1 is always the same as the statement of the claim if it can be, and in this case it can. So we know so much. We already know it's a left-tailed test. We do know that we're going to have to get the P bar and Q bar now, so let's go get those really quick. P bar would be the 15 plus the 27, all divided by the 343 plus 294. So we got 15 plus 27 yielding 42 incidences of malaria in all their study. And they looked at how many kids? They looked at 637 kids. So if I take the 42 and divide by 637, I get the most common experience that it goes on forever. So what's Q bar? Q bar is 1 minus that. So keep it as a fraction over 637. Ask yourself, what's the makeup from 637 and 42? And it's 595. So 595 is the Q bar that needs to be used. So 595 plus 42, right? If you looked at 595 plus 42, it should bring you up to the 637. So that's our background stuff. So what are we able to do? We're able to go get our test statistic by saying, hey, you know what p hat is? It's 15 divided by 343, right? Or p1 hat. P2 hat is the 27 over 294. P1 minus P2 is always 0. And so you can leave that off, but I'm going to put it there for emphasis in case somebody's reading the book and solely off of that. All over the square root of P bar Q bar. Well, P bar is 42 over 637. Q bar is 595 over 637. And all over N1, which was 343. Plus 42 over 637 times 595 over 637, all divided by 294. And we're going to run that guy. So I promise you this is the biggest work that you'll have in any of the sections. So just be patient with it. You're doing less work by keeping the fractions even though you might not be enjoying that. It's way better than writing down a bunch of decimal places and hope that you copied them correctly. So I did the top subtraction, hit equals. Now I'm going to hit divide by, and then get your square root, and then don't do anything other than just type in what you see. 42 divide symbol, 637 times 595 divided by 637 divided by 343 plus 42 divided by 637 times 595 divided by 637 divided by 294. And we hit equals. And we get a z-value that seems pretty appropriate, negative 2.438. So z-values are normally rounded to 2 decimal places, and all do the same, negative 2.44. You can take a moment like I'm going to do right now and just make sure that that test statistic matches, and we match it perfectly. And so you know already, because the alternate hypothesis is pointing to the left, the symbol in it, this is a left-tailed test. What are we going to do? We're going to put the significance level in there. And if we roll up, the significance level that they asked us to use was 0.01. And so we got a 0.01 going in there. We're going to look up that 0.01. We're going to find it in the back of the book. We're going to find 0.01. And it's not going to be there exactly, but it's going to be related to 2.33 like you've seen already in chapter 8. So awesome. That's what we have so far. So are we going to reject? Of course we're going to reject. We're rejecting the null hypothesis for the same reasons that you did in 8.2 and 8.3. The test statistic is in the tail. So there is sufficient evidence to support the claim that, and then I'll just look at what number 16 says, that the incidence of malaria is lower for children using bed nets. So we should be advocating bed nets. Okay, awesome.